Hey everyone, and welcome to the final video in our prime numbers / introducing indices series. Now, all I'm going to do here in this video, hopefully it's not too long, I'm just going to bridge together the two main concepts that we've been talking about in this series. It's a very short series. All we're looking at is, first, the idea of prime number decomposition. So breaking any number into a product of prime numbers. And the second thing we're doing is we are using the indices and writing things in index form to help us to write numbers in a more concise way. Once we get these products, and some of them may be really big, we want to get this in a way that's very easy to read and interpret. So, very quickly, let's just look at an example of the number 60. And I want to break this up into a prime factor tree. So, two factors of 60 that I know. Hopefully, this is a revision for a lot of you. All we're doing is the same thing we've been doing up until now, but we're just using what we know about indices just to tidy this up a little bit at the end. So 60 I can break up into 5 times 12. Now 5 is a prime number, so there's nothing more I can do here. Whereas 12 is a composite number. So I can break 12 up into 3 and 4. And now 3 is a prime number. 4 is still composite. So we want to break 4 up into a product of its primes. So 2 times 2. And once I get this, once I've decomposed this, I can now write 60 as 5 times 3 times 2 times 2. And what do we know from indices? Well, we know that this here, 2 times 2, we have the same base multiplying by itself. So indices tell us that I can write this thing as 2 to the power, so 2, which is the base, to the power of however many 2's there are timesing. And here we have 1, 2. So we write that as 2 squared. And my other numbers remain. So this is like saying 5 times 3 times 2 squared. This is how I can decompose a number using my prime factor trees, which we've been doing up until now. And now what we can do is once we get it to its decomposition, we can apply what we know from indices. Now, you probably don't really have that big of an appreciation for this right now because 60 is still a relatively small number compared to how big these can get. Let's try an even bigger number. So let's do, for example, the number 800. So a much bigger number here. I'm going to write this. Well, two numbers that multiply to give me 800. Well, one of them is 8 and another one is 100. So 8 lots of 100. And now that I get here, well, I can break 8 up into, well, 4 times 2. And this 4 I can break up into 2 times 2. And my 100, I have 10 times 10. This 10 I can break up into 5 times 2. And same with this one, 5 times 2. So I can decompose 800 into 2 times 2 times 2 times 5 times 2 times 5 times 2. And therefore, I can say 800, let's do this in another color. I can write this as 800 equals 2 times 2 times 2. I'm already getting bored writing all these 2's. You can hopefully see where I'm going with this. Times 5 times 2. Okay, that was a lot of work just to write down all of those products. And I know from my work with indices so far is that I can just count. I have a lot of the same base numbers here, right? I can just count how many there are multiplying and apply my abbreviation, apply my shortcut, my indices that I know. So how many 2's do I have? Well, I have 1, 2, 3, 4, 5 2's. And how many 5's do I have? Well, I have 1, 2 5's. So therefore, my very last step is I can write 800 as I have 5 2's timesing. So I can write my base 2 to the power of 5. And that is going to get multiplied by my base of 5 to the power of 2. So you can imagine as my numbers get really, really, really big, as I'm working through my prime decomposition, my factorization trees, I'm going to have a lot of the same numbers multiplying by each other. And this is where indices, getting this from my expanded form, expanded form to my index form is very useful. It just saves me the work, right? As I said before, the moral of the story, guys, mathematicians are lazy. We just want a shortcut way to write things because we're not bothered writing 5 2's multiplying by each other. It's easier to just come up with a type of shorthand like a base 2 to the power of 5, something that communicates the same information just in a condensed way. So that is how we can combine everything we've learned so far with prime factorization as well as indices. Thanks so much for watching, guys. I'll see you next time.